This video is on dividing monomials with positive exponents. Here we have n to the fifth divided by n squared, which literally means I have 5 n's on top and 2 n's on bottom. If I cancel out 2 of those n's, it leaves me with 3 n's on top. So my answer is n to the third over 1, which can just be written n to the third. Now we don't have to write out these n's every time and cancel them out. Just in our head, we do subtraction. 5 n's minus 2 n's is 3 n's. When you are multiplying monomials with a common base, you add the exponents. When you are dividing monomials with a common base like this, you subtract the exponents. So in your head, what you do is you just say 5 minus 2 is 3. Let's look at another one. Here I have bases of g's and bases of h's. On the g's, I have 3 on top, 1 on bottom. If I started canceling out, I would cancel this g, would cancel one of these out and leave me with 2 on top. These two h's would cancel 2 of these out and leave me with 5 on top, just like here. But that's not really the way I have to look at it. I can just subtract. On my g's, 3 minus 1 is 2. And on my h's, 5 minus 2 is 3. And that is my answer. Example 3. Well, actually, here's one for you to try. So on the x's, 3 minus 2 is 1. 1's understood. I don't write it. On the y's, 4 minus 1 is 3. Number 2. On number 2, 7 minus 5 leaves me with 2 k's up top. 10 minus 3 leaves me with 7 m's up top. And 1 minus 1 leaves me with 0 p. So my answer is k squared m to the 7th. Number 3. On number 3, I have a common base of 8, so I can subtract the exponents. 8 minus 6 is 2. And since this is such a small one, the answer on the test may be 64, or it may be 8 squared. Number 4. On number 4, I got 4 b's on top and 4 on bottom. They all cancel each other out. 4 minus 4 is 0. They're gone. On my c's, 6 minus 3 is 3. On my f's, 8 minus 5 is 3. Your answer is c cubed, f cubed. Number 5. On number 5, I have 8 g's on top, 7 on the bottom. 8 minus 7 is 1 g. On my h's, 2 minus 1 is 1. And on my m's, I got 1 on top, none on the bottom, so it stays. My answer is GHM. Number 6. Number 6 was a little bit different. This is the first time we've had coefficients to divide. Negative 21 divided by 7 is negative 3 for my coefficient. On my w's, 5 minus 4 is 1. And on my x's, 2 minus 2 is none. They go away. Your answer is negative 3w. Number 7. On my coefficients, 32 divided by negative 8 is negative 4. On the x's, 3 minus 1 is 2. Y's, 2 minus 1 is 1. Z's, 5 minus 2 is 3. Your answer is negative 4 x squared y z cubed. Number 8 is a little bit different. Give number 8 a try. Well, number 8, if we subtract 4 minus 6, we get negative 2. We'll learn later what to do with a negative number, but for right now, if you have one like this, think about it like this. I got 4 on top, 6 on bottom. When they cancel out, I'm left with 2 on the bottom, and I have to have that placeholder up top of the 1. There are understood 1 coefficients. So the 1 up here has to stay. The 1 on the bottom, I don't have to write. It's understood beside the n squared. Try number 9. X over x cubed. On number 9, I got 2 more on the bottom than I got on top. Have to leave my placeholder up top, 1 over x squared. Before we learn about negative exponents, that's the way you need to think of one, where your bottom has a bigger exponent than your top. Now let's talk about zero exponents. Anything to the 0 power equals 1. So on example 1, I have all this stuff in parentheses. Everything in parentheses is to the 0 power, so everything in parentheses equals 1. On example 2, I have x to the 5th, y to the 0 over x cubed. The y to the 0 equals 1, and 1 times x to the 5th is just x to the 5th. So basically, I ignore the y to the 0 power. I could mark it out if I wanted to, and just concentrate on the x's. 5 minus 3 is 2. The answer is x squared. Try number 1. On number 1, on my b's, 4 minus 2 is 2. On my c's, 2 minus 1 is 1. And on my d to the 0 power, it equals 1. 1 times all that is understood to be there. So b squared c is your answer. Try number 2. On number 2, I've got a lot of stuff going on, but it's all in parentheses, and everything in parentheses is to the 0 power. So everything in parentheses just equals 1. Try number 3. Number 3 is multiplication, not division, but we needed to see one with a 0 exponent. So my coefficients, 2 times 3 is 6. On my ends, n to the 4th times n to the 0. 4 plus 0 is 4, one way to look at it. Or as soon as I see n to the 0 power, I can just erase it. Don't even have to write it to start with. It doesn't matter. It's just an understood 1. 1 times 3 is 3. So you could write it without that, just a 3 there. Zero exponent, one of the easiest things we'll do. Now we'll do power of a quotient. When we were multiplying, I call this power to a power. If you put this in your calculator and you put parentheses 2 over 3, parentheses to the power of 2, you could get the answer. But if I were doing it without a calculator, I would want to think about the numerator and the denominator separately. So in the numerator, I have 2 squared. On the denominator, I have 3 squared. And 2 squared is 4, 3 squared is 9. The answer is 4 nines. On example 2, 2 times 1 on the a's give me a squared, and 2 times 2 on the b's give me b to the 4th. Example 3, I have 3 things to apply this 2 to, the 3, the n, and the 7. So 3 squared is 9. 2 times 3 gives me 6 n's, and on the bottom, 7 squared is 49. Try number 1. Up top, 3 cubed is 27. 4 times 3 on the x's is 12. And on the bottom, 4 cubed is 64. I said 3 times 1 on this exponent to get 3. 3 times 4 on this exponent to get 12. 3 times 1 on this one to get 3. Try number 2. On number 2, the square applies to the 5, the x, the y, and the 6. 4 things. So up top, 5 squared is 25. 2 times 5 is x to the 10th. 2 times 1 is y squared. On the bottom, 6 squared is 36. So your answer is 25 x to the 10th y squared over 36. Number 3. On number 3, I have 4 things to apply the square to, the 2, the y, the 3, and the z. On the 2, up top, 2 squared is 4. 2 times 2 gives me y to the 4th. On the bottom, 3 squared is 9. 2 times 3 gives me z to the 6th. Number 4. Well, number 4 up top. 3 times 2 gives me 6 A's. 3 times 7 gives me 21 B's. And 10 cubed is 1,000. If you have a base of 10, it's really easy with exponents. An exponent of 2 would be 2 zeros. An exponent of 3 would be 3 zeros. An exponent of 4 would be 4 zeros. 10 to a power is easy to write. So 10 to the third power means I have 3 zeros, is 1,000. 8 to the 6th, b to the 21st over 1,000. And that is your video on dividing monomials with positive exponents. Thank you.